Hey everyone, how are you doing? In this video, we're going to go over the example from video 202 on electric charges. So, more specifically, this example is called quantization of charge. We just learned in the video that charge is quantized, which means that charge comes in multiples of electrons or protons. You can't have something that is charged up with 1.5 electrons, for example. It has to be 1 or 2, etc. It has to be an integer number, integral number. So let's look at the problem and we're going to work through it. I'm going to try to guide you through it. And I really encourage you to pause the video every time I ask a question so you can really think about it as we go over the problem. This problem says a plastic rod is rubbed against a wool shirt, thereby acquiring a charge of negative 4.8 microcoulombs. How many electrons are transferred from the wool shirt to the plastic rod? So the first thing that you want to do is figure out, what is it asking? Okay, so hopefully you can see that it's asking how many electrons are there. And then the next thing is to figure out, okay, well, what's the relevant equation? What am I given? So think about that, and you'll see that we're given one thing here, that there's a charge of negative 4.8 microcoulombs. So I'm going to go ahead and write that on the next page, which has more room here. So think about what variable that you're going to write down for this negative 4.8 microcoulombs. You never just want to write a number, you always want to write down what the variable is. And we defined the variables in video 202. So go ahead and write down the variable, which hopefully you wrote down Q. Q stands for charge. And whenever you write down a number, you always want to figure out or write down what the prefix is equal to. So think about what micro is equal to, and go ahead and write that down. So micro is equal to 10 times negative 6. So you should write down Q equals negative 4.8 times 10 to the negative 6 coulombs. We're looking for how many electrons there are, so the next step is to figure out, well, how am I going to represent that as a variable, and what is the relevant equation? So think about that for a second. And we've only learned one equation so far. So the only equation we've learned, hopefully you can write it down, is Q equals plus or minus NE. So hopefully you identified this as the correct equation for this problem, because this equation talks about the quantization of charge. Always know what each variable stands for. We already talked about Q as charge. N is the number of particles, the number of electrons or protons. So in this case, how many electrons? We're looking for that number. So N is our unknown. That's what we're looking for. And then E is the charge of an electron or proton. So it's the magnitude of the charge. It's 1.6 times 10 to the negative 19 coulombs. All right, so write down everything that you know. And what do you think the next step is? Well, the next step is to go ahead and solve for the unknown variable. I like to do that before plugging the numbers in. Now, before we do that, look at the plus and minus here, and remember what we talked about for this equation. If the charge is negative, which it is, then just use the negative in the equation. So when something is charged up with electrons, use the negative. When something is charged up with protons, use the positive. So in this case, we can rewrite the equation as Q equals negative NE, and then we can solve for the unknown, which is N. So we're going to go ahead and let you get N by itself. Pause the video if you need to. But what you're going to do is you're going to divide both sides by negative E. So you're going to get Q over negative E, which is the same thing as negative Q over E. And finally, you can plug in the values. So negative times a negative 4.8 times 10 to negative 6 coulombs, and then E is the charge of one electron, 1.6 times 10 to the negative 19. Again, it's just the magnitude of the charge. E is always a positive number. You can see that the coulombs cancel out, and you're going to be left with just a number. When you plug this in the calculator, the negatives are going to cancel out, and you're going to get 3 times 10 to the 13 electrons. And this is a totally reasonable number. When things are charged with protons or electrons, it's usually not going to be one proton or one electron. It's going to be a huge number of electrons or protons that are charging up the object. So hopefully this clears up how to use this equation for quantization of charge. You can figure out the number of electrons or protons using this equation, or if you know how many electrons or protons there are, then you can solve for Q and find the total charge on an object. See you next time, everyone. Hope this was helpful.